Hello, hello everyone. Hello everyone who joined SaugaTalks today. I am Irene, if you know already. So today we will be talking with Imtiaz Adam, who is a known authority in artificial intelligence. Imtiaz is an AI executive and strategist. He has a pedigree in business and computer science. He's a known authority and influencer on Twitter in particular. If you don't follow Deep Learn 007, you should, because that's what I do, and that's where wisdom and knowledge coming from. So Imtiaz, welcome to SaugaTalks. Hi.
Thank you very much, Irene, for hosting me and inviting me.
Absolutely, this is my pleasure, because what we will be talking about today is AI, surprise, surprise. And we're gonna touch some topics, we're gonna touch some angles of the conversation, because frankly, we hear the news, we read lots of information out there. But being here with expert of your caliber, I really want to understand a few things. How businesses should treat AI and what we're dealing with right now, because there are practical applications, there are use cases, but at the same time, there is adoption barriers which each business is facing. State of technology today, very broad question, and maybe we'll touch the future state. Where do you see this is going? Welcome.
Yes, no, thank you for that introduction as well. I think, first of all, if you kindly allow me to say a couple of words about myself, and thank you for that very kind introduction. I come from a bit of an unusual background in that I served as director of Morgan Stanley, the investment bank, and come from a business school MBA and mathematical finance background. But then I also went on to study AI and machine learning at postgraduate level afterwards, with research in areas such as deep neural networks. I believe this is a very exciting area, but it's also one where we can get a bit carried away sometimes, in particular with some of the hyper expectations about what AI is and where it really is the reality of today versus where we think it's going to go in the future, or what the Hollywood movies tend to show. So I think coming back to focusing in on your point of AI and, let's say, machine learning, which is a bit of AI that really works in the real world, and deep learning, which is in turn a subset of machine learning. I think that's a good starting point to look at where we are, where we're going. So when you go back to the early pioneers of artificial intelligence, back in the 40s, /50s, I say 40s, you could say Alan Turing and others around that era, with the Turing machine, etc., and the Turing test, right at the Turing test, and in particular, and the imitation game, as it was called. And the imitation game was a game whereby if you had someone on the other side, I say someone, and it was actually a machine or a person, and the person speaking to it didn't know whether it was a human or a machine, and whether or not they could be fooled into or tricked into believing it was a human rather than a machine. And that's often referred to, that imitation game, as the Turing test. And although there are some who claim that it's been passed today, many, myself included, but many indeed professors in computer science or AI would say it's not been passed yet. And the fact that it's still debatable tells you arguably it hasn't been, because if it had, it would be very clear. And that tells you, even as far as we've come, we've still got some way to go in AI, in terms of being able to do things like common sense and understanding things like sarcasm, etc., that humans tend to do, to have a real general human conversation, in spite of where we are with the latest things like GPT-3 that we'll talk about in a moment. But if we take a step back, the early versions of AI in the 50s all the way up to, say, the 1980s, the types of techniques that were particularly prevalent then, and in the 80s, it was in particular the expert systems and things like symbolic AI or logic were very prevalent at that time. And the early types of algorithms that we had in that period, the 50s, to, say, that period of the 80s, which have been things like the search algorithms, breadth first, depth first, etc. They were not really intelligent and they were brute force. We did then start to develop things like heuristics and things like the A-starred algorithm that were more less brute force and a bit more intelligent. However, none of those algorithms, and including things like the expert systems, really scaled well in a world that is not black and white, in a world that includes grey, a lot of grey. So deterministic systems that were prevalent in the early AI type, or types of AI used in the early days, tended to work well in deterministic situations where the world was either white or black. But as we know, there's a lot of uncertainty in the real world, and so they didn't really scale well. And then we came to the era of machine learning in the 90s and early 2000s, and then after that, deep learning, albeit deep neural networks have been around for longer than that, with the early architecture of neural networks going all the way back to the work of the perceptron with Fred Rosenblatt and others. I think a couple of research scientists from the former Soviet Union and Ukraine in the 1960s as well, and early 70s. And then the work by Jeff Hinton and Rubenhart and Jeff Hinton in 1986 with their paper in Nature, which kind of brought back propagation. Now, if we look at machine learning essentially is applying data and learning from that data. And it is a subset of artificial intelligence. And likewise, deep learning in turn is a subset, arguably, of machine learning, according to many. So AI is like the general umbrella that we catch all these things under. Deep neural networks refer to neural networks which were loosely inspired by the brain, the biology of the brain. And they're called deep because they have several hidden layers between the input layer and the output layer. Otherwise, it would be a shallow neural network. And these deep neural networks have really driven a lot of the revolution in AI over the last decade, in things like computer vision with convolutional neural networks, with text to speech, or speech to text rather, and neural translation with what used to be recurrent neural networks and LSTMs, but now is increasingly transformers with attention mechanism, of which GPT-2 and GPT-3 are types. And what's led to this move forward with advancement of AI, in particular machine learning and deep learning, has been the advent of large sets of data as we've moved to this era of digital. And if you think about it, the advent of smart mobile phones, the internet, etc., and social media has led to explosion in data. In fact, I think IBM have a statistic which they've released in the past that 90% of human data in the history of humanity was created in the last 2 years, and that keeps on changing all the time as we get more and more vast amounts of data. Then you look at someone like Statista, the consulting company, who point out that in the period to 2025, or by 2025, we will have forecast to have 75 billion connected devices, internet connected or IoT devices. That's an average of 9 per person on the planet. That's huge, which is going to generate vast amounts of more data. And what machine learning and deep learning do very well is basically making sense of that data. It's too fast for humans, it's too big, the velocity, the veracity, the volume. And therefore making sense of that data and then having the human analyst or the human team being able to take actions on the basis of that data or actionable insights. Some of which is true, some of this insights will be automated. For example, you can have sensors and make automated responses to what you detect from that sensor. But in other cases, you may be looking at analytic tools where you're looking at data, historic data that the machine learning can make sense of, and then you try to make a decision based on that or validate that decision. So it's not necessarily machine learning or deep learning replacing doctors or humans. Doctors, I gave that example where it's been cited before by some researchers that, hey, a radiologist will be replaced by deep convolutional neural networks. Or, well, actually, maybe it's going to be that we help the radiologist and others and dermatologists, etc., do their jobs more efficiently and take the strain off them rather than necessarily replace them.
It's human augmented, right? It's not
Correct.
replaced. That's what you're referring to? Yeah,
Correct.
yeah, yeah, yeah. Would you like to dive deeper into industry applications or just talk about general business directions where each business can take advantage, like low-hanging fruit in what technology has to offer?
Yes, why don't we deal with both, I think, at the same time? I think that's very important. So essentially, if we come back to looking at the areas of machine learning and deep learning that have been particularly successful, we tend to find things like, for example, boosting algorithms, and the types of those tend to be things known as XGBoost, light gradient boosting that came from Microsoft a few years ago, and cat boost, which came from Yandex of Russia a few years ago as well, tend to be very good with things like tabular data and making sense of those or actionable insights from those. Deep learning tends to really excel with areas such as computer vision, where convolutional neural networks have had large amounts of success on training sets and then performing on things like medical imaging and, for example, fashion object detection and classification, and then recommending similar items for fashion, etc., would be one example. So visual search, detecting object detection to detect an intruder, for example, on a security camera. Navigation for an autonomous vehicle would use a CNN typically. And then it's been areas like neural translation, where we've had the transformers and attention mechanisms of the last few years, and in particular of the last year rather, have a big impact, of which one of the headlines recently has been on GPT-3, which has been trained on 175 billion parameters. So that's a huge, vast machine learning model. And it's been crawling the internet, things like Wikipedia, etc., to learn. And it's a NLP, natural language processing, or NLG, natural language generation model. So it's been a real step forward in NLU, natural language understanding, because for a while NLP, this area of NLP and NLG had kind of lagged behind computer vision. Like if you went back 3 or 4 years ago, a lot of the surge, if you like, in AI and deep learning was happening on CNNs, convolutional neural networks, and computer vision. And now we're seeing rapid advancement in the field of language with transformers. It's a complex mechanism. I won't go too much into detail, but it uses a network of multiple encoders and decoders with something known as self-attention mechanism, and where it's been very effective and had an advantage over techniques such as the recurrent neural networks and LSTMs that were used previously, has been, for example, the ability of transformers to focus on very long sequences and the sentences, and therefore through the particular mechanism that's been used with self-attention and the encoder-decoder network to kind of understand get better understanding or better language translation that had been previously possible before. It is not, however, artificial general intelligence. It is a big advancement in AI. It is a big advancement in the field of natural language and NLP for AI. But it is not. It does not mean that you have to quake in your boots that tomorrow Skynet is going to come and wipe you out.
No, not yet, not yet. So AI is not gonna write our music from now on. It's not gonna create movies for us. It's not gonna do our work for us and continue our presence in this world. I mean, I know it's very vulgar what I'm saying right now, Imtiaz, but it will be great to hear from you. How do you comment on the big news of the new promise?
We have been seeing things like, I don't have the actual statistics, but we do see increased amounts of, for example, with journalism and on the internet, more articles that are being written by bots, if you like. We do
hopefully not too many of them, you know, but yeah, it's definitely a technical, right, capability.
We are seeing encroachments into these areas. We are seeing situations where things like GANs, generative adversarial networks, which is from the field of computer vision, that Ian Goodfellow helped create or inspiring, well, did actually create in 2014.
Mm-hmm.
We've seen these areas with the GANs, which use two deep neural networks, which are competing together in a zero-sum game. You have the generator, and it's like two neural networks that are essentially, you have what, I'm trying to think of the best way to describe it. It's been described as the fraudster and the expert.
Mm-hmm.
The generators creating, if you like, the fake images, or the images which are ultimately fake, really. And you've got the discriminator, which is judging them. And the generator keeps on getting better and better until hopefully it gets to the point where it can fool the discriminator. So imagine it as being the generator being the fraudsters creating the fake banknotes, and the discriminator is the one that knows what the genuine banknote looks like, and they keep on giving criticisms or feedback to the fraudster until the fraudster can actually fool the generator. That's a very simplistic way of describing it. And these techniques potentially, along with CNNs, convolutional neural networks, combined with GANs in the movie industry, in the film industry, maybe we're going to see more synthetic media, as it's called, going forwards, where artificially generated movie sequences may come through. But it is going to take a bit of work yet. There are some who say, for example, in fashion, that we may have artificially generated fashion models in the future. In particular, when we get to 5G and we get augmented reality, mixed reality really take off at that point, and the machine learning continues to advance. However, I think if we bring it back to where we are today, AI, and particularly machine learning and deep learning, is a tool to help make sense of things, make sense of the data. But if we're coming back to the business side, I think it's important for a business to the business management to understand, first of all, what is their objective? What are they trying to achieve? Are they trying to enhance the marketing operation? Are they trying to improve their operations, cut costs, improve profitability, more conversions with the customer? What is their goal with the machine learning before they embark on it? And also, what is the data that they have and how they're currently capturing it? You need data for a machine learning project. And it's usually better for those companies that are new or relatively new to the field to start simple. Start with a simple project. Don't go to the most advanced areas like deep reinforcement learning, or playing around with a GAN from deep learning, for example. If you're new to the field, as a company, start simple. And because going through that exercise, they're going to, the company and its internal team are going to understand what they've got, what they've not got, what problem points they're going to hit. And as you pointed out, try and hit the low-hanging fruit, the easier things to tackle, rather than getting lost for 1 year, going around in a circle and coming out feeling they've wasted a lot of time and resource.
We've seen a lot of disillusionment, okay, because promise was huge a few years ago, and company who embarked on the journey without preparing the data or preparing the thinking or leadership, there was, of course, natural disillusionment that came, that technology is not solving every business problem. Guess what, right? So I guess smarter approaches now being developed. And one of them you pointed, start small, right? Grow big, achieve small success, and then publicize and just attract more followers by doing what you're doing. But this is a general practice. But technology is there, right? So now it's in humans' hands. So.
Yes, no, absolutely. So if we take that back a step, Gartner, for example, published, I think, at the end of 2018 and republished, I think, in early 2019, that 85% of machine learning projects were failing to deliver the expected value. And the 3 reasons that were given: number 3, quality of the data science team. So it's important that if a company is going to go into the area, they invest properly in the team. There's nothing wrong with giving younger, more inexperienced, if you like, staff a shot at that. But you need someone in the team who's actually brought something to production before. So don't think you can just do machine learning or data science on the cheap, which some companies are trying to do, or outsource it to people you don't know who what their experience is and what their track record is. You need someone in that team at least one, preferably more, who've actually brought something to production before. Because going through, integrating into the client's back end, making sure something's been properly tested and validated, that the whole machine learning pipeline, etc., into production is quite a intensive process and requires a lot of experience or knowledge. So that's important. The number two reason was the availability of data. And often, you know, machine learning doesn't work without data. We talked about why are we in this revolution right now? We're in this revolution because mobile smartphones took off about a dozen years ago. The internet, social media, etc., generate a lot of data. And you look at who's the strongest companies in machine learning. There's no accident that it's Google, that it's Facebook, that it's Amazon, etc. The company, Microsoft, you have LinkedIn, of course. Companies with very, very large sets of data or access to large sets of data are the ones that develop some of the most advanced machine learning. Then you, so making sure you have sufficient data, and that data, how are you capturing that data? Where is it stored? How does it have, what pre-processing are you going to have to do to that data for delivering? There's the expression, of course, garbage in, garbage out. So if you're feeding you can use the most powerful deep neural network in the world, but if you're feeding it garbage and training it on garbage, it's going to give you garbage back. And then the number one reason was the fact that the team, the data science team, worked on something that was of no value to the company. And that, I think, can be viewed as a communication failure in my view, that the data scientists typically talk one language, and the business team, be it marketing or finance, for instance, talk a different language. And the two have a completely different understanding, perhaps, of what's expected or the deliverable. Maybe the marketing team or the finance team, whatever, the strategy team, are imagining that they're going to get some, you know, flying robot, something amazing that can do artificial general intelligence, and the data scientists have a completely different view of what they're expected to deliver. Well, they wouldn't be able to deliver that flying robot with AGI anyway. Not at this moment in time anyway. But I'm using an extreme example. And I think increasingly we need the data scientist team to start to understand the business team better, and for the business team to start to understand data science better as well. The business team may not get to the point of understanding the coding, etc., and more of the advanced mathematics or statistics, but they at least need to understand the key limitations and capabilities and terminologies. So, and likewise for the data science team, they have to understand the business priorities as well, and what they're looking for in terms of return on investment. What should they target on the ROI that's expected to deliver? So it comes back to trying to formulate the objective and the problem we're trying to solve clearly. Are we trying to increase, are we trying to tackle churn rates of customers? Are we trying to expand the customer base, going for promotional activity or targeted promotions to customers? Or are we trying to reduce costs on the operations and the supply chain? What are we actually looking at? What's the most important thing right now for this company? And what data have we got to actually enable that within the company? So I think that's going to be very important in terms of the framework. But if we start to look going to the future, which is where I get very excited in terms of where we're going to go to, and we can already see a number of trends that have been developing. Some cynics say, well, you know, as you pointed out, there was a lot of hype of AI 3 or 4 years ago, and hey, we don't have level 5 autonomous cars today, and we don't have artificial general intelligence today. Therefore, AI has failed, and we're going into new AI winter. An AI winter, we've had 2 before, one in the 70s, and then the other when the Lighthill report and DARPA in the UK criticised the state of AI, and at DARPA, the US Defense Agency, reduced expenditure on AI. And then we had a second one in the mid to late 80s, around 87, 88, when the expert systems market kind of collapsed. And that led to the second AI winter. I subscribe to the view that we're not going into a new AI winter, in spite of what's been happening with COVID, etc., the COVID crisis and tragedy, resulting in a recession or potentially, who knows, even a depression. Hopefully not, but because the following, if anything, COVID has shown that we're very heavily reliant on digital. Companies that had a strong digital presence, such as Amazon, use a lot of AI, have fared much better than, for example, in the UK, we have Primark, which is a fully physical store. And those examples of those who are purely physical and didn't have an online presence are the ones that perhaps are very heavily hit from COVID-19 and the resulting economic crisis. So if anything, digital transformation is going to accelerate, which means in turn, demand for AI and the need for AI or machine learning is going to increase. Equally, when we get into the era of 5G, which is on its way, and we're going to have more connected devices, more Internet of Things, IoT, and that vast amount of data that's going to get generated from connected sensors and connected devices is going to mean that we're going to need more and more machine learning and deep learning on the devices around us to make sense of that data and generate actions in response, often real time or near real time, on the fly engagement with customers, etc.
And making better decisions, right? Making better decisions based on those recommendations. Yeah.
Correct. So if we take the example of an autonomous car, they may take a bit longer to get to level 5 than some had hoped a few years ago. But maybe as 5G scales and we get more and more advancements, maybe by the end of this decade or 2028 to 2030, I've always felt post 2025 is a more realistic period to look at major advancements in autonomous vehicles, at least towards getting level 3 and 4 vehicles more and more on the road. However, an autonomous car needs to make decisions on the car itself. It can't wait for a signal back from a remote cloud server telling it to stop or turn left or turn right, because A, you might lose that signal, or B, there might be latency, and then in the meantime, it can make the wrong decision and crash or do nothing and someone else hits it. Yeah. Same with robotic surgery and industrial robots, etc. Increasingly, they'll be making more and more decisions on the device itself. So that world of edge computing, which is intelligence on the device, is something we're going into going forwards. And we have had advancements in AI, people overlook that often. We're getting constant incremental improvements, and even in the techniques that are coming through. So for example, we talked about attention and transformers, which came around, I think, about the last 2 years, and really started to take off in the last year with GPT-2 and now GPT-3, BERT from Google on neural translation. And also when we go to federated learning, which is a technique that Google introduced, Google also introduced transformers, but federated learning in 2017, but federated learning has really started to take off in the last year to potential wider applications. In fact, we talk about the challenge of data, for instance, and the fact that right now, a lot of the data is being held by the technology majors and the social media giants, which arguably gives them a advantage, some may say unfair advantage, in machine learning and deep learning over some of the legacy companies and startups. And healthcare is a good example. Many AI startups get into healthcare, but then they get the initial funding and perhaps then after 3 or 4 years don't scale in the way they'd hoped to, because the hospitals, for example, healthcare providers are very reluctant to share data because they have concerns about data privacy. Likewise, banks and insurance companies are very protective of their data. And in Europe, for example, there's GDPR with very heavy fines. And the US, there is also equivalent, there are also rules on privacy, etc., that affect the healthcare sector. So federated learning is a means by which we could potentially solve for the data privacy and data security challenge. And an example of how that works, or at a very high level, how that works for the business audience. We start, as we do today, with machine learning on the cloud, train on the cloud, but then we can then place that machine learning onto across distributed servers. Now, this could be, for instance, mobile devices, and it's forecast by some analysts out there, but by 2022, we'll have over 1 billion mobiles, 1.25 billion, I believe, according to Forrester research. 1.25 billion mobile devices will have a GPU, a graphical processing unit, on them. A GPU is like an AI chip for the sake of simplicity. GPUs have also been very important in the advancement of deep learning, and or making deep learning more scalable or accessible. And so more and more mobiles are expected to have these in the next 2 to 3 years. So we may see more and more AI or deep neural networks embedded on the mobile itself. So you could actually do federated learning on the mobile device. You don't remove the data, but you, when the model, if you like, the learning, for want of a simplistic explanation, goes back to the aggregated model. So the model in the cloud, the general model at time t0, does the initial training. So federated learning is a technique that many in the field hope is going to help solve for data privacy and data security. It's a relatively new area that Google introduced in 2017 and is starting to get some traction over the last year or so. And basically what we do is we start with a general model that's trained on the cloud as it is today, but then you can deploy that onto mobile devices. So for example, it's forecast by Forrester Research that by 2022, 1.25 billion mobile devices will have a GPU on them. A GPU is an AI chip that makes, if you like, deep learning or more accessible. Now, you would then train on the individual data set on that mobile, or as NVIDIA did with King's College Hospital last year, on distributed servers in hospitals. And then that learning that's been done on decentralized data then flows back to that global model. But you never remove the data from the local server, or for instance, the mobile device or the local hospital. What happens is we update the parameters, which is like the mathematics of the model. So the gradients and the weights would get updated in the global model, and then you redeploy it to everyone. So all the mobiles, or in the case of NVIDIA working with King's College Hospital, all the hospital servers. So you get collaborative learning without removing the data. I'm explaining this at a very high level in a simplistic way. There are some criticisms that there are risks of what's called adversarial attacks, that you could still hack into that transmission between the, for example, the mobile device and the cloud server, although there are others who say you could put encryption on that to try and reduce the risk of that. But if, as these kind of techniques such as federated learning and differentiated privacy that go with it become more and more viable and scale in the future, we should then start to see a real material advancement of machine learning in areas such as healthcare, where data privacy has been kind of the limiting factor or stopping it from scaling. So I'm very hopeful that in 2 to 3 years, areas such as healthcare, banking, and insurance, where data privacy is very, very important in data security, we'll start to see more and more machine learning coming through with areas like federated learning with differentiated privacy. So I think the next 2 to 3 years are going to be very, very exciting of bringing machine learning and deep learning onto the devices around us as we get more and more internet connected devices, and we'll get near real-time interactions. So in your home, for instance, you could have a system that can detect that your window is open and the aircon is on, or the heating is on, depending on what season it is, and automatically close that window or shut the air conditioning or heating off in that room. So we get less wastage, which means less issues with climate change, etc., greater efficiencies and lower electricity bills, right? Win-win.
Great reasons to be optimistic. Great reasons, because in the speakers here on SaugaTalks, I'm asking for some takeaways to leave our audience with some positive outlook to the future, because we see all the negative outlooks everywhere. So I would like to touch on those, please, because technology is helping us to shape our future. And this is what we're still in control of, I hope, to some degree, as humans. So between, technology and then humans, where we're going to be.
So I believe that we're about to enter a period where change and the pace of change is going to be faster than any point in human history. The digital transformation is going to accelerate more and more. AI is going to become literally pervasive all around us. we'll get, so right now, as I mentioned, the Internet of Things is a bit dumb. It's not an intelligent journey, or, you've got sensors, but a lot of things are not intelligent around us.
You need to know what to pull, right? Where to look almost. You need to know a lot of things before getting valuable information.
Well, and we're going to get to a situation where when we deploy deep learning and machine learning on the devices around us, we can have real-time engagement on the fly. And that's going to open a whole new world that we don't even imagine today. An example is in China last year, a surgeon conducted remote brain surgery on a patient 3,000 miles away. So miles or kilometers. Anyway, one of the two, it's a long way away. And on the brain, and it was successfully concluded using 5G. So that's the world we're going into, where we've already seen with COVID-19 during many parts of the world had lockdowns or regional lockdowns. And then you became very reliant on digital, working from home, deliveries to home, etc. So the digital footprint, if you like, is growing, and the need for AI to make that a more efficient journey, more personalized, we'll get more and more hyper-personalization. If we look at the retail sector as a good example, retail sector has been constantly suffering. The traditional legacy retailers, many of them keep on disappearing. And yet Amazon has gone from strength to strength because Amazon understood it. Jeff Bezos understood the power of data, the power of AI machine learning, and scaling that from an early stage. Alibaba in China too. Many of the retailers, apart from new entrants such as Zalando, have been slow at understanding that, and they've got to change or disappear. Having said that, the flip side is, when you look at the retail sector, wastage has been huge. Depending on who you believe, it generates every year between 300 billion to $1 trillion of wastage on inventory, etc. Unsold items, both food and fashion, clothing, apparel, some of which just gets destroyed. That's not economically efficient nor environmentally desirable. So if we can get to a world using machine learning where we can personalize and better determine what should be produced and how we and sell it more efficiently, then that's going to be good both for the actual retailers in terms of their profitability, but also in terms of the environment, for instance, in terms of reducing the pollution, etc., and better allocation of resources. That's one example. Industry 4.0 is going to be very exciting too, as we go to a world of really exciting new possibilities. Areas such as augmented reality and virtual reality that struggle with 4G because of latency are going to work with 5G. And new standards such as JPEG XS, which was launched about a year ago, which is new, enhances the compression and works nicely with 5G. So we're going to get to a world as 5G gets more and more deployed, where AI and 5G will work together to really completely transform the consumer experience with holographic technology, with real-time interactions with things around us. More and more merger between the physical world and the digital world, I believe, is really going to be the essence of the 2020s. That this decade, and I'd say in particular the period 2022 to 2029, that 7-year journey is really going to be about more and more across, or even up to 2030, of course, I'd say is going to be very much about the physical world and the digital world more and more merging into one. And in the 2030s, it's going to be more about 6G and quantum computing, etc., and other things altogether, and maybe flying cars, who knows. But I think this decade is really, really about bringing physical and digital more and more closer together with AI on the devices around us. And we're also seeing exciting research, which is in fairly early stages, but advancing, from the likes of MIT CISA, which 2 examples of papers they published last year, which are very exciting. For example, one known as the lottery hypothesis ticket, which is showing how, with deep learning, we need very large data sets, and it's very time-consuming process of training, or can be, if you're starting training the model from scratch rather than using transfer learning. And the lottery ticket hypothesis showed how they could use pruning to make the process more efficient, and has a lot of exciting potential. Equally, there is a paper called the Neurosymbolic Concept Learner, where they brought together deep learning with symbolic AI, two areas of AI which traditionally have been rivals. And by fusing them together, we're able to make the deep learning work on smaller sets of data, which will be important for areas like autonomous robotics, and where we want to do things on the edge, on the fly, because then we could train on smaller data sets as well as inference and inferencing in real time, but also train and learn new things on smaller data sets, and have real-time engagement with the world around us. So I think these kind of things are going to be very exciting over the next few years. We're not going to, in my opinion, get to artificial general intelligence. AGI, for those who don't know, is kind of things you see in the movies like Skynet, the Terminator, iRobot, etc., where the AI can multitask, can be aware or conscious. People have big debates about that. Will AGI ever be conscious or not? Will AI rather ever be conscious or not? And what is consciousness? And you get into philosophical arguments around that. Mm-hmm. We won't get there this decade, in my opinion, and in the view of many other leading researchers, because who are out there who comment on AGI, because the barriers are quite formidable, and examples are the kind of things that you need to get around. For example, even the most powerful deep neural network suffers from something called catastrophic memory loss. So you train it on one thing, and then when you train it on a second task, it forgets the other task that it originally learned. So you have AlphaGo Zero, which uses deep reinforcement learning, or AlphaGo rather, which beat Lee Sedol, the world Go champion, 4 years ago, and reached the headlines. But if you go and ask AlphaGo, it's raining outside, should I take my umbrella? It can't tell you that simple thing, because it's learned one task, which is how to win the game of Go, and it can do that very well. To the point, it could even beat the world champion, but it can't give you a common sense answer about taking an umbrella for rain. Mm-hmm. And to do that, many say that we may have to actually, some have talked about transfer learning, a huge network of transfer learning between convolutional neural networks, which was a PathNet paper from DeepMind a few years ago, where agents keep on transferring knowledge from one to another. But others say we'd actually probably have to go beyond that and actually replace the backpropagation algorithm, which is at the heart of deep learning, with a new approach. And that's going to take a long time to solve for. Another problem is the energy efficiency and memory problem. You know, humans are very, very energy efficient. Our brain, you could, if you had to, not for a prolonged period of time, not for weeks on end, but for a given day, if you had to survive on, you know, a few glasses of water and a few apples and a banana or whatever, and still perform.
How much fuel we require, right? Every second. So yeah.
But when we go back to AlphaGo, for instance, it required, I think, 1,200 or more than that CPUs and 175 or 6 GPUs to beat Lee Sedol. Huge amounts of server capacity, huge amounts of energy being fed into it to beat a human at one game. So, you know, humans have millions of years of evolutionary efficiency in us. So it's going to take time for that to happen. I think it's unrealistic to people to say, oh, you know, we're going to get AGI bang like that. Some teenagers will be in their parents' garage playing around with their laptop and AGI will magically appear. It's going to take a lot of research and effort to get there.
That's a good news. That's a good news. We keep hearing how machine winning over humans more and more, right? In a bunch of applications, but looks like, yeah, good point you're bringing, right? Energy efficiency.
Well, I think we often look at the world as we see it today. And I think at the point where we are approaching AGI, we're going to be much more advanced ourselves. We still don't know a lot about the human brain. And if we don't know a lot about the human brain, it's still a challenge for us to create AGI, because with AGI, we're trying to create, for want of a very simplistic or better explanation, a very simplistic explanation in artificial human, or something that can be, a computer that's replicating a human brain, more or less in a very simplistic way, or rather a simplistic explanation of it. Something that can generalize and multitask in a way that a human brain can, and match human performance on tasks. Well, to do that, many say we probably have to look at biology and the human brain itself to get there. Some disagree, but many do say that. And for that to happen, we would probably know a lot more about the human brain ourselves. And I believe at that point, we will be in the world of 6G, who knows, maybe in 7G, who knows what the future will be there. And we will be increasingly augmenting ourselves, maybe with human computer interaction with brain chips, etc., to advance our own capabilities more and more. So I don't think it's going to be at that point in the future one day, and I don't think, again, that it will be this decade, that some AGI will appear and crush humans per se, because I do believe at that point humans will be much more advanced in our own capabilities, with more and more interaction with AI and fusion with AI in the future to enhance ourselves.
I like the future you're describing. I like it very much. I do want to bring some hope to those who want to be part of that future. What about these digital skills? What about the professional and, just general job skills that people need to acquire? Because many thinking and rethinking, right? No matter if you're just entering the world, the business world, if you're right mid-career or close to retirement. So where do you see, right, these new professions being born, and what's the opportunity for more people taking advantage of this digital economy?
I think that's a very good point. And I think we should actually focus on the immediate priority, which is going to be the COVID crisis, both in terms of the human tragedy, but also on the economic consequences that will follow. And we're in a situation where unemployment all over the world is trending upwards, where a number of companies are disappearing and more will disappear. A number of companies have managed to survive because of government bailouts and furlough schemes, and the likes of the UK and elsewhere in the US, support that's been given to those who've been furloughed or made temporarily unemployed, if you like. However, at some point those schemes are going to end, and unfortunately many people are going to be left without a job when in the next few months perhaps. So not just the next few months, but next year or two could be very challenging for many. And I think it's going to be very important for our policymakers, for our politicians and regulators, to look at the ways in which we can deploy emerging technologies such as AI, which covers machine learning and deep learning, but also the technologies that 5G will avail, like augmented reality, virtual reality, etc., more Internet of Things areas, to create new businesses and new whole new industries that don't exist today, to create employment. And sometimes I've had like a researcher in AI write to me and say, oh, how is an AI company create more AI companies going to create more jobs? Well, actually, it's not just the programmers, it's not just the machine learning developers. You're going to have marketers, you're going to have salespeople, you're going to have HR,
data specialists, right? Data, who preparing data, right?
You're going to have DevOps, backend. You Google, for instance, has a huge number of employees, and they're not just machine learning engineers or one type of developer, for instance.
Amazon hiring, right, a large spectrum of professions, actually.
Correct. So if you go back and chart, actually, the employment growth that occurred since 2012, which is when deep learning really took off, arguably, when AlexNet, which was a team, which was Jeff Hinton's PhD team, or students from Jeff Hinton of Toronto University, won the ImageNet competition. And ImageNet is like the equivalent of the World Cup of computer vision. And they destroyed the opposition using deep learning and GPUs, graphical processing units. And that's when the likes of Google and Facebook, etc., got very excited about deep learning and really started to get involved into it. And arguably that was a key moment when deep learning really took off, even though it had been around before then. And But then you look at the employment growth in Google, in Facebook, in Amazon, in Alibaba, for instance, another example, companies that are very heavy on AI. And if it was true that AI just is going to lead to unemployment with complete automation, then these companies should not have increased their employment, and yet they did dramatically. And the paradox is the unemployment since that period has come from the legacy companies that have been slow on adopting digital and other technology and AI, for instance. So it's been the companies that have been more and more stuck in the past. And I remember my business school professor in strategy at London Business School, he was at Stanford, did his MBA at Stanford, and he reminded when the glasses, when you look at in the frames of your glasses, those who wear glasses, we often look on what's immediately in front of us. And we forget what's here in the corner of our eye. A good example that he gave was the advent of the calculator. Until that point, people used slide rules for calculation, calculating things. And the slide rule had been there for hundreds of years in universities, in schools, in industry. And the slide rule manufacturers were really focused on each other as competitors and almost making a brass finish. So the other made a chrome polish finish, etc. And the calculator came out here, the likes of Casio, Japanese, etc. And it was here in the corner, and they didn't really view it as a competitor or take it seriously. And within 2 years, they were all gone. They were all wiped out by the calculator. And we have a similar situation here, whereby I believe that around 2022 to 2023, as 5G really takes off, and we see more and more AI come through on the edge, etc., and more rapid digital transformation, those companies that are laggards are probably going to increasingly disappear. But we need to try and create incentives for new startups that can come up and grow rapidly to create employment, and especially in the wake of many people being unemployed now, and over the next year or so as a consequence of COVID-19 and the economic consequences that followed. We have to view technology as a way to go out there and generate new business opportunities and do things in a more efficient way without making the same mistakes that we were making 20, 30 years ago with heavy industry. We don't need to make them again. We can find ways to optimize renewable energy, to use AI and other new technologies and things like battery storage technologies, which is still relatively embryonic, but use that to enhance the R&D and future capabilities in these areas so that we can create more and more industry 4.0 technology companies that are more and more efficient and bring efficiencies through the entire value chain.
In terms of skills, in terms of, where people can help themselves preparing, right? Do you see any, again, low-hanging fruits, low entry barrier into professions that would lead them to prosperity later?
I think there's another very important point, which is hyper-personalization. Personalization has been a holy grail for many businesses for a long time, but many have kind of struggled to get there. And as you try and create differentiation strategy, especially in the modern era, remember now the young generation that are out there, whether they be TikTokers or Instagrammers or whatever, this is a generation that increasingly don't remember a world that wasn't digital. It's a generation that was born and grew up with the internet, that for them, the convenience of an Amazon or doing a Google search or whatever, or using social media is second nature to them. It's something they were born with or grew up with. And this is a trend that even with COVID-19, for instance, my mother adopted e-commerce. She didn't use it before. E-commerce, and now she does
this digital transformation at personal level. Yeah, totally.
Correct. And now she feels very comfortable with e-commerce and is going to continue with it. So increasingly, businesses have to understand they really have to work with data, become data-driven, and use that data to personalize services or products. They can do much more sophisticated segmentation, for instance, than they could before, and really get to drill into customer segments and what's driving those customers and what kind of strategies they need to adopt there. And that's for services, that's for products, and also on their own operations internally in terms of how they can make things more efficient and understand what problems they face and what are the costs of those problems, so that they can then understand how to target them better. So that's increasingly, I think, going to be the optimistic and real world use cases of machine learning going forwards.
Perfect, perfect. An opportunity for people who are thinking and rethinking their own life strategies, right? And even changing professions nowadays. Imtiaz, thank you so very much. We talked about future, we talked about present state of machine learning and AI, and thank you for educating us, right, on where things are. Thank you for describing the bright future. And I appreciate your time here. So I will link your information because you are enormous source of articles and wisdom, collective wisdom on Twitter, particularly LinkedIn. So I'll definitely want to invite our audience to follow you and to get more of these pearls of wisdom from you. Thank you so very much. I appreciate it.
Okay, thanks very much. It's been a pleasure. Thank you.